Yay! Okay, great. So, as I said, what I'd like to do for the second half here is look at several possible solutions. And before we dive into the possible solutions, it's a good thing to remind ourselves about the two kinds of challenges. So most of what we were going to be looking at has to do with figuring out this question, right? Is there any fact that I meant plus rather than quas? So I'm going to talk several times about like the fact and what the fact is or what it consists of. This is what I mean, right? It is the fact that I meant plus, not quas. The other thing to note is this normativity element. It's going to come back a couple times. And again, we'll try and re-emphasize it when it does, but it's useful to have both of those points in mind. It's not just that I do answer 125 when asked about the addition question, it's that I should. So there's a justification for my answering one way rather than another.
That there even is a correct answer.
That there is some kind of correctness involved, right? Not just that this is the answer you output. So that's going to come back a couple times as well. Right? But again, we're going to talk about this, and when I say the fact, it's that we meant plus rather than quas. And there's this normative aspect rather than just the purely descriptive aspect. Okay. So, and I love this poster. It's actually on my, so you know how we all have to make posters for the hallway? This is on my poster, because I love it so much. So the first two possible solutions that we're going to talk about, one of them we've already talked briefly about, this notion of an algorithm, but the first one's really flat-footed. It's just like, no, my past use solves the problem. The fact that I meant addition consists of the fact that I used plus as a symbol for the addition function. My behavior was consistent with doing so, and that's why it is so. Now, this is really just included to make sure that we have a grip on the paradox. This is not going to help. We've only performed a finite number of past computations, so our past actions are compatible with lots of different rules. This finitude is, in fact, compatible with an infinite number of different meanings or rules for that. So, thanks for playing. The second one is slightly harder and more interesting. So this is, I think, again, kind of articulated a couple times. Let's think about the fact that we could characterize the rule with an algorithm. So the fact that I meant addition consists of the fact that I adopted a specific rule or algorithm. And this rule or algorithm singles out the addition function. Effectively, we have a rule, the algorithm, that's telling us to obey this rule, the addition rule. Now, the problem is that we could run the same case with the algorithm, with the rule for following a rule.
But couldn't you say that the algorithm is the rule? They're equal?
Then we'd be right back down to the past uses. Because it would be...
Because an algorithm is not a use.
But it would be then, we'd be questioning not which rule we're using, it's which algorithm are we following. The problem is that our behavior would then be compatible with an infinite number of algorithms. If you collapse the algorithm down to
the behavior, yes, but the question is not what the behavior is, the question is what rule will you follow? And you could stipulate that by saying, okay, this is my algorithm.
Good. So, you stipulate that this is your algorithm. Now, let's ask. Your past instances of applying the algorithm are going to be compatible with the plus algorithm and the quas algorithm. Does your past behavior settle which one of those two you're actually using?
No, of course not. But I can tell you my algorithm.
Good. But we could say the same thing with the addition function too, right? We could say this is what I've done every time. And this is the broad idea. But of course, that's compatible with there being a certain... Sorry, I know, I saw your hands. that's compatible with there being a certain point in the future where we differ. I think that what you're trying to push at is basically a version of this aspect, right? There's some intention that I have, and I can articulate what my intention is, but your intention there doesn't guarantee that that is actually the thing that you've been doing.
And if I were to if I were to formalize my algorithm into a machine, I can build a machine that just counts marbles, and there are 2 inputs, and I can put the marbles into there, and every time a marble goes past some counter, it goes up 1. Good. And I could say every time I write down plus, I mean that thing.
Good. So we're going to talk about that in a second too. So one thing that we would have to ask is, if the machine spiraled back down and started spitting out 5 every time after a case, would it be doing it wrong?
Well, it couldn't, because it's my invincible machine.
But you see the kind of problem here, right? So we encoded a particular kind of rule, a particular kind of behavior from the machine, but if the machine had this radical diversion at some point, would it be wrong?
Yes, okay, I get, yes. So it's dependent on some other, but I mean, if with like the Platonic ideal of an algorithm, what Paul was referring to, this wouldn't be an issue, right?
Cool.
Well, you can't be wrong. It is by definition what plus means.
Yeah, that's totally fine.
This is what it means.
But note that then the question is, how do we know which Platonic form we are instancing?
We could label it, right? We could just say this Platonic form has this
Nice.
sign, and nothing else can have that sign.
Absolutely, right? But one problem is, how do we know which one we are picking?
Write it down.
So again, we can think about it this way, right? The Platonic forms are basically going to correspond to every one of the functions. These functions are, up until a certain point, there's going to be an infinite number that overlap. So when we tag one of them with our plus sign, we either then need to specify every single output with the infinite number of potential outputs, it's that form, or we're picking a massive overlap of different Platonic forms. Does that make sense?
But you could have a formalized rule, right? Just take the 2 and put them together and count the result. I mean, why couldn't that be the algorithm?
Good.
Just that.
For example, the algorithm is the outcome is 1 every time, right?
Yep.
That's an infinite number of outcomes. So of course, with all past usage, there is an infinite number of other algorithms that are consistent with it, but there is in the Platonic form there is only 1.
Good. So that's an easy one, because in that case we've sorted out the infinite number of responses. Right. Now let's try and do that with what we're doing here.
Yeah, but with addition you can do the same, right? It's a bit more difficult probably, but
that's the trick. In a sense, you could, but what you need to do is then define a higher level rule that tells you why that behaves this way, and that higher level rule will be apt for the same problem. We have to express it, we have to then characterize it, and all of our past applications of that higher level rule will be more grist to the, instead of quas and plus, it will be meta quas and meta plus rule.
So is the problem then these infinite regression, so that in whatever way we express our algorithm, that expression is also
going to be more grist to the problematic node.
Yeah, because that's what we were talking about in the break, and we agreed that would be, I mean, a valid response. But is that actually what is said here, or is this another?
So in a sense, right, the worry is that the rule for interpreting the rule, right, the algorithm, if you like, so was putting it in this way. We can call the algorithm the kind of meta rule, and the rule this just what the plus function is. If you don't like that terminology, you can read it another way. The algorithm, the rule for following a rule, will be just subject to the same skeptical hypothesis.
So in what sense then is this a new paradox? Because it seems then to, I don't want to say just be, but then just seems to be the fact that of no single thing the meaning can be established without referring to other things. And that's one that sort of.
So it's not just that, right? It's not just that it fixes other things, but that at every given instance, we're going to have a worry about how any kind of facts are going to fix the meaning. So even a holistic attempt at a solution isn't going to help.
So this is another variation of the we can't fix meaning problem. Or okay.
I mean, again, right? That's the skeptical solution, right? That's the thing we're supposed to take away, right? Nothing is going to justify ascribing any particular meaning to any particular thing. And that's going to hold even if we take all of language together.
So is this new? Is that because I think I feel like I've already seen versions of the we can't fix meaning.
In a sense, right? Again, it's getting us back to the same result that we had at the very, very first argument. But what it's trying to do is to think about this sort of rule following, which should be so easy for exactly the kinds of reasons I think you are worried about. But it turns out that there is no justification for saying we're following any one rule rather than another. So it's a different route to get us to this same result of there's no fixing meaning. In that sense, it's a familiar result, but it's going via this kind of case of we should be able to fix meaning by thinking about following rules. We can't even fix when we mean we're following rules. That's the truth. Yeah.
Okay. You just had it before this about the disposition to utter something.
That's our next one, yeah.
Okay, because you can say idealistically, like infinitely, I would have the disposition to like use the plus instead of the plus.
Yeah, we'll come to that. One more slide.
Okay, and then one little more question that I think you guys already discussed. Why can't we make, instead of the result, make an inference in the method? And then we look at the infinite methods and we say, okay, I make the inference on the plus because a plus, it leads to like beyond the 75, it leads to a specific answer which
Cool.
differentiates it from the other.
So this is where the second part of the challenge comes in. Right? So in that case, you would have an explanation for the descriptive behavior, but you would have no answer for the normative aspect. Why should it be going towards 125 rather than 5?
Okay, yeah.
Why would the person who answers 5 be doing it wrong?
Yeah, I think, yeah.
You could say, oh, they're just not following this one. But cool, why is it wrong? That's the kind of normative aspect. Normative aspect, that's the word I'm looking for. Right. So, again, the first kind of thing is if we appeal to this algorithm, it's just the same problem again, one level up. And there's a slightly weaker one, which Kripke mentions, but it's not that interesting, which is that most of the time, people who use things like addition or any of these kinds of broad rules can't express the rule for the rule. And if they can't do that, then there's no way for them to justify their particular uses. Again, this is a slightly less interesting one than the top one. Because if the algorithm is just another kind of rule, then we can run the same problem again. And note, I think that another kind of thing that's underlying your concern here is, hey, we should be able to clearly and fully specify. Absolutely. Because again, we could just do that for all inputs, return 1. That's a good one. That's not going to be very helpful in the kind of addition case, because then, yeah. What we have.
I added it as an example because it's probably the simplest algorithm you could think of.
Yeah. Yeah. Input, just return input. Right.
Yeah, that's another one.
Times one.
Yeah.
Times one.
Yeah. That's a trick because we have to know what minus means. So that's the other kind of thing. If we read this, if we think of these just all of them as tables, so you'll have a column with input and then a column with output. It's very easy to understand these. It's when we start to characterize the table, like what you jokingly did about like it's -1, we have to know then what's the function of -1. So we're right back then to, in order to fill out the table, we'd have to understand what minus is, which means appealing to another table, which is then going to be subject to this kind of skeptical
but
worry.
there is an important difference between a table and an algorithm, because an algorithm specifies in one concise description an infinite table.
Good.
And you cannot write down an infinite table.
But it's going to use functions. Unless it's just well, even if it uses identity, right?
Yeah, it's also a function.
Yeah. So in those cases, you have to understand what the functions included in the algorithm mean. This is why it's basically a rule for using rules. Mm-hmm. And so then we're off understanding those.
Yeah, I think many mathematicians would say that the algorithm is the rule.
Yeah.
They are the same.
I think so too. And then what we can come back to.
That's not the question. The question is the correct rule.
Yeah.
That's every time.
Yeah, but that question then becomes meaningless, right? There is no correction. This is the algorithm.
Exactly.
So.
Good.
Paradox.
But then if there's no kind of correct answer, then answering responding to this with 5 is just as good.
Yeah, not if you stipulated that you have to use this algorithm rather than that one.
Yeah, good.
Because the addition algorithm will
have
125 as an answer.
That's in a sense the question, right? When we use this word, how can we be sure that we're mapping it to the addition algorithm rather than the quaddition algorithm? We might be able to formulate them, but we don't have any justification for saying this word tracks that one rather than that one.
You first have to agree upon that. Yeah.
Okay. So again.
So this would work in a private language, right? I can agree with myself that plus maps to this.
So this is why it's kind of tied up with the private languagey stuff. There's a sense in which all of this looks good, and then you disagree with yourself. There's a sense in which this looks good, but when you start to kind of provide the justification, you have to do it using the same words you're trying to justify, and so you could never get the whole process off the ground. That's actually the reason why Wittgenstein thinks private languages are impossible. You would never have anything out there for your words to kind of hook onto, so you couldn't even begin to articulate the language to yourself. You would just be making noises, and you would think that the noises are meaningful, but they're not. It's a trick of, so here's another way to come back to it, and I'm sorry, because this is coming back to the logic stuff again. But if you remember, we have this difference between object languages and meta languages. So one of the things we can do is we can define the object language symbols using the meta language. I tell you what the little hat means. It means conjunction, but I have to tell you that in English. I can't tell you that in the logic itself, in TFL or FOL or whatever. If your private language is both your object and meta language, there is never going to be a sense where you can articulate the rules. And it's effectively the same worry here, right? If the algorithm is something we're expressing in English or an extension of English, then the same concerns we have about articulating the base level of English are going to apply at the meta level too. We can do it with the formal logic versus meta language because they're different. In this case, we couldn't because the algorithm is going to be re-expressed in the same language. So the meta and object collapse. You look concerned.
Yeah, I was just thinking about my private language where I agree with myself. But so in defining things in your own private language, because I'm very Cartesian, I could agree with myself, I could refer to my own conscience within myself, and thereby perhaps know exactly what is meant without having to express it in some...
So one of the things you have to do is figure out how my conscious, or whatever word you want to use...
I don't use a word, I just use the immediate sense
of
my conscience.
But then it's expressing it in a private language, right? You need to have some kind of word to represent the thing for it to be part of the language.
I couldn't have a sense. My private language can consist of my sense of my own.
Senses aren't parts of language. They're the things that language expresses. So a sense is distinct from the bits of language. It's what gives the language the meaning. So in that sense, no, you could have a sense, right? but it wouldn't be part of the actual private language there. It's good. It's a useful kind of thing to come back to some of the stuff we were talking about before. Okay. So again, if the algorithm just turns into like rule for rule, more gress. Another idea, and this has already come up a few times, right? This dispositionalist approach. All right. So the fact that I meant plus rather than quas consists in a disposition. And this disposition is a kind of modal property. It's not that, right, whenever I am confronted, it's that were I to be presented with x plus y, then I would respond with their sum rather than their quab. So again, even if I've never seen this, I have this disposition to respond with 125. I lack the disposition to respond with 5. And note, there might be some questions about why I have the disposition, but that's another thing entirely. This answers the skeptic, or at least prima facie answers the skeptic. And again, the thought is, right, you can have a disposition that's never enacted, right? This glass, well, I don't have a good one. This cup has the disposition to melt when sufficient heat is applied. That'll be the case even if the cup never melts. Right? So dispositions don't have to be enacted to be possessed. Okay. First problem, dispositional solution. Pretty weak, but still useful. Everyone is disposed in some cases to make mistakes. So either we aren't disposed to mean addition, or there's something else that's doing the real work to lock us in to the particular behavior. This is kind of Kripke's formulation. Note it's a little bit cheap. Yeah.
But if they don't have to be enacted, the dispositions, and they still apply, isn't that the same thing which we discussed with the induction and the chairs, since everything has set disposition?
We don't know which dispositions things have.
Exactly.
That's on the next slide. Right? No, it's good, right? So important to note in this one, we'll come back to this point, important to note that the is disposed to is cheating a little bit. Because it's not like things are disposed to make mistakes, it's that they do.
And someone is conceivable who would do addition
Who could be
perfectly
perfect.
every, yes, who would do addition perfectly every time, right?
Yeah. This is why it's kind of a weak beginning, right? Think about this as if we're asking us, we who I assume none of us are actual perfect computational machines. Right? That's the problem here. Right? Put another way, you can have a disposition and it can be foiled. Right? That is, even if you're disposed, you might fail to respond in the way that your disposition inclines for various reasons. A stupid example, but it's one that comes in the disposition literature. The mug is disposed to melt at certain temperatures. Right as it's hitting the temperature that this thing is supposed to melt, we zap it with like a freeze ray. So the disposition is foiled. The trigger condition is achieved, but the result, the response doesn't happen because of an intervention. That's something that can happen here, blocking the disposition.
My disposition could be conditional on the circumstances being perfect, right?
Lots of different things, right? Lots of different things. There's ways to move around this. The slightly more interesting objections here, the first one, is effectively a finitude problem. Right? As Kripke says, not only is my actual performance, but also the totality of my dispositions finite. The thought here is that, and this is contentious, but it's an interesting argument, our dispositions only apply to a finite range of cases and will be compatible with an infinite number of different functions. I know, that's the response I make too. So the thought here could be either expressed in an epistemic way or in a metaphysical way. The metaphysical way is what we've got here. The disposition itself is finite, and it kind of breaks down after a certain point. I see no reason to say that.
I mean, there are cases for which I have no disposition and to which I then wouldn't respond, but then that would be my disposition, right?
Yeah. But no, again, then that actually would mean it's not tracking plus anymore. It's tracking this weird case. So that would be a problem for the skeptic as well. Or not a problem, but good for the skeptic, bad for us. But even if we avoid that kind of metaphysical one, this comes back to the point you made just a second ago, right? The way we get a grip on the disposition is going to be finite. So we don't know which disposition is actually there. It could be exactly like the one you just said, where, cool, it applies to an infinite number of cases, but at a certain point it just kind of shits the bed and spits back, I don't know. Or it could be the one that perfectly maps the way we want addition to work, but every bit of evidence we would have perfectly overlaps, so there's no justification for saying it's one rather than the other. So again, if you read this metaphysically, if you read the challenge epistemically, it's got a little bit more bite. The last objection is kind of the more interesting one, which is that the dispositionalist doesn't give us a good answer with regards to normativity. It tells us that we do respond, it doesn't say that we should. As Kripke puts it in the bit here, right, the relation of meaning and intention to future action isn't just descriptive, it's normative. I should respond with 125 rather than 5. And if we violate the disposition, it's not like we're doing something normatively wrong, we're just violating the disposition.
Couldn't you say that an algorithm has a disposition to certain kinds of inputs, and in that sense that we would do it wrong if we don't respond the same way the algorithm would?
So there it's descriptive, you're not responding to the algorithm or responding as the algorithm would, but it's not clear why following a different disposition is violating the normative aspect.
Because our word, of course, refers to that specific algorithm. So plus refers to that algorithm. We need to respond the same way the algorithm would, and otherwise we're...
So what would then happen is we would say this about the algorithm. Right? Which one we're tracking is more grist to the skeptical mill. Maybe each one of those gives you a particular normative response, but we don't have any reason to say that we're following one algorithm rather than the other. We can layer these things, right? Okay. So the disposition one seems plausible, especially if you're already inclined to see dispositions in many places. But it walks back into these problems. First, there's this issue about error. Second, there's this problem about the infinitude of our dispositions, either metaphysically or epistemically. But most importantly, it doesn't answer the second part of the challenge, right? That there's a normative aspect here. The normative aspect is not being explained, just descriptive. We don't respond, but why shouldn't we? The second one, and this comes back, I think, to one we talked about earlier, we might push the dispositions out wider and say that it's not a particular individual's disposition, but it's the community that I'm engaging with. Right? So the fact that I'm at plus consists in the fact that most or all members of my linguistic community have the same disposition, that when presented with x plus y, they'll respond with the sum and not the quum. This is nice because it avoids the error issue, but it might walk into a community-wide error problem. That seems much less feasible. But the other 2 points still stand, right? If the dispositions are finite, especially in that epistemic sense, then the same objection applies, and the normativity kind of fails. We might get a case of normativity, and this might be where you want to go. We might get a kind of sense of normativity in like, you should conform to the community-wide things. And there's a sense in which that gives us a kind of normativity, but it doesn't explain why the answer with 5 would be wrong in any kind of like, in any broad sense, right? If the real explanation for normativity is this is what everyone around me would say, that's a pretty weak justification for addition rather than quaddition, right? So this is just kind of a follow-on from the dispositions. Here's one. What about a perfect calculator? We had this a second ago. Right? So let's suppose that we're error-free. So the fact that I'm at plus consists of the fact that were I or my community free of mistakes, we're error-free, then we would have been disposed, when presented with x plus y, to respond with the sum rather than the quam. Cool. How do we define perfect calculator? It looks like what we'll have to do is evoke the very rule that we're trying to explain our following, which then means the characterization of perfect calculator is just going to be subject to the same kind of broad skeptical worries as we had when following the rule. Right? So to say that the answer is wrong or that a mistake was made is to assume we're following the rule, which is what we're trying to prove rather than what we can assume. Effectively smuggling in the notion of following the rule to the notion of perfect calculator. And note, we can kind of appeal with this. Instead of putting this at the level of the disposition, you could put it at the level of following the algorithm, which then has the disposition. Again, you can layer these different stories on top. The same broad problems are going to kind of follow through. Here's one that I think is interesting. We might have a kind of machine solution. So the issue here is us. Maybe our meat bags are bad, but we could encode the rule into some machine, either a physical machine or not. So the fact that we mean plus rather than quas is that there's a machine that obeys the rule I want to follow, and I'm mirroring it. Or I'm trying to mirror it. Maybe that's probably better. So if it's a physical machine, right, we could build it or we have it. In this case, we've got a calculator, which is supposed to represent, or at least it's one of the many functions that a calculator does, right? It can do addition. So a machine like a calculator embodies the addition function just in case, when given two numbers as input, it outputs their sum rather than their quam. Cool. Take any given calculator. It will only have ever done a finite number of sums. What happens when it outputs 5 for something that's clearly not adding up to 5? Put another way, what guarantees that the physical machine is obeying the addition rule rather than the quaddition rule? There's a really good joke about this in one of the Douglas Adams books, so in the Dirk Gently books. He has a calculator that when you get a sum that's above like 38, it responds back with a suffusion of yellow. Now his calculator, if you don't ever get above that number, is doing addition, but obviously if you get above that number, yeah, it's pretty clearly doing something like quaddition. And it's actually a joke on this rule following paradox stuff. So cool, we can embody it in a machine. How do we know that the machine is actually following the right rule? Note, we could appeal to the dispositions of the machine, but then this is just the dispositionalist count all over again. We could do it not as an actual physical machine, but something like a machine program. Cool. We don't need a physical object. We just need a program. This is just the algorithmic response all over again. Because that's basically what you'd be defining. You'd be defining a kind of algorithm that this physical object or immaterial object follows. Cool, that's another rule. That's subject to the rule. Da, 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 da. Everything we said before. I think the one that's probably the most, or at least I find the most intuitive, is this kind of simplicity response. So I meant addition by plus, partially due to disposition, and partially because when it's indeterminate, which meaning an expression has, the simplest of these is automatically assigned as meaning. The simpler conception is just better. And the idea with quaddition is it's disjunctive. It's either give me the sum or give me 5.
But it's simpler, right? Because if your numbers become too high, it's easier to say 5.
It's easier to say 5. In some sense, it depends on how we characterize simplicity. It's simpler in the sense of it's a smaller range of outputs, but it's more complicated in the kind of formation of the actual function, the rule, if you like. But you're already starting to see what's going to be a problem with this. Yeah.
And also, I mean, if you, for example, do some practical physics and you try to plot some kind of graph, then the computer oftentimes for some random data from some 12 log or whatever that indeed explains quite nicely those points and goes completely crazy outside of the range. So you could, in what sense is it simpler? Because it's just one very complicated function.
Overfitting is effectively the problem. Yeah. This is going to be a huge issue here, right? So there's kind of two problems, and it cuts both ways. One way is that, right, simplicity is relative. So if we start with plus, we would then define plus as a disjunction. It's effectively, remember I mentioned the GRU versus green. So we could define GRU as green until time t and blue after, or we could define green as GRU until time t and then bleen after, where bleen is the opposite, right? Blue until time t and green after. Beautiful. Which one is simpler? I don't know. Depends on where you start.
Plus is quas, but it's responsive addition.
Yeah. When it should be 5, it's responding with addition, right? You respond with plus or quas up until this, and then you respond with sum instead. Yeah. It's silly, but no, it's by definition, it's going to be interdefinable. But maybe more generally, right? And I don't know how much to make of this. Like Kripke says, right, I don't justify my choice of 125 rather than 5 by citing a hypothetical simplicity measure of the kind mentioned. It seems to just be intuitively the wrong kind of justification for why we're saying 125 rather than 5, setting aside all of the worries about how the hell to characterize simplicity, which are genuinely deep worries. Okay. So, again, what did we try to do? I tried to articulate this paradox which targets this mathematical function only because it's such a clear instance where it feels like we can articulate the rule. And by trying to articulate this rule, it turns out that our past behaviors are going to be perfectly compatible with our having met lots and lots of different rules. Plus doesn't necessarily mean plus. Plus could mean quas. And this is a big, big problem. And it's a big, big problem not for any of these kinds of things, right? But because it seems to suggest that there is no way for us to guarantee that our words mean what we think they mean. Because the same stuff is going to apply to every single kind of word. One possible exception, we might be able to get away with direct demonstratives. Because and this is kind of coming back to your my feeling, right? Direct demonstratives might be such that there isn't even really a rule underpinning them because of how they function. But you ain't going to get far with just those.
And we could actually write them out, right? We could say, well, we're just going to make a finite list of all the responses to addition, and then that's just what we mean by addition. And if you want indeed to add something very big to something very big,
keep going.
Too bad. But we can
just basically say
formalize a reasonably sized system. We should be able to formalize, right?
Yeah. In a sense, what we'd be doing then is kind of, cool, it doesn't matter which one of the infinite rules you're using. We're just only going to stay within the bounds where they overlap. That's totally fine. That's kind of weird. But it's a way forward. What happens if you add numbers bigger than 57? Shh, stupid question. Don't ask. This is kind of similar to an objection we talked about with Grice. So if you remember, the Gricean project tried to ground meaning in terms of intentions, this circular intentions. And the big issue with this Gricean project is it looks like there are meaningful sentences that no one has uttered, that there have been no circular intentions behind. So we might think that there's a similar kind of problem with the like, we stop. It's like, well, it looks like I should do addition beyond this. It's like, no. But yeah, so the big thing here is that it looks like there needs to be a solution. There has to be. But it isn't really clear exactly how the solutions are going to go. Or at least Pache all of the objections we talked about. So that's really the things I wanted to go through here, right? I really like this as a kind of puzzle because what it implicitly does is it brings us back around to the problem that we started with in lecture 0, where, all right, we have this kind of idea-founded conception of meaning and of language. Well, the ideas are the sorts of things that are locked into our own heads. They're not necessarily communicable, kind of by definition. If that's what language is about, then there is no communication. If the rule-following paradox is the case, note, even if we have things like Phrygian senses or descriptions or whatever, we're still screwed. Because we can't determine which sense we're expressing with our language. We're stuck. So it's a kind of interesting little circle or loop to come back to. And I love the puzzle. I don't think it's necessarily unsolvable, but I think it's fun to think through. Exactly as you were expressing earlier, it's frustrating. And in the way that I think so many fun philosophical puzzles are. It's like there's clearly a solution, and then you float one, and it's like, God damn it. Okay, but that's broadly where I wanted to go for today. So talking a little bit about next week. So next week, what we're going to do is we're going to talk about truth and fiction. So in particular, I have 2 broad topics that I want us to kind of talk about. The first is going to be the basic semantics behind truth and fiction claims. And we're going to get 2 different broad accounts. The first one that we're going to get, which will be spelled out in the reading from Lewis, thinks of truth and fiction as truth in fictional worlds, sets of fictional worlds. Sets because of an issue about incompleteness. And this is a really neat paper. It's a classic in these sorts of debates. Have a read through it. We'll talk through it. The other thing we're going to look at in this same semantic question is a broadly Waltonian view where truth in fiction is understood as true according to a pretense. Now, these 2 are very similar, but they behave differently, and they have different treatments of the core concept of impossible fictions. Fictions that include impossibilia, either contradictions or stuff that are just necessarily false. So that's one big topic. The other big topic I want to talk about is going to be, we'll call it a very broad notion of fictional incompleteness. So fictions are often gappy, and these gaps can take different forms. So not all fictional gaps are the same. And I want to try and talk a little bit about that next week. Now, this isn't going to be in the reading, but this is something we'll talk about. So this is up. I put it on the Canvas page. It's in the files, but I'll put a link to it also in that kind of Canvas homepage so you can see it. I'll make an announcement linking it, all of that. This is what we'll talk about next week. But importantly, right, thanks for coming. I hope that was interesting. And yeah, we'll see you next week.
Are there sentences about fiction which are true in one account and false in another?
Yes.
Okay.
Yes. So the really cool one is basically if we take well, we're going to talk about it next week. Yes.